Assalamu alaikum everyone, welcome to another video about introduction to Python. In this tutorial I'm going to talk about comprehensions and especially about list and dictionary comprehensions, and we'll also talk about single line if statements. Comprehensions are a feature we can say maybe just for it is just for Python, and using this type of loops makes your code very Pythonic, and also it makes it much faster than usual for loops. So without further ado, let's begin. So we are going to talk about the following 5 topics, and we're going to start with single line if statements. What are single line if statements? The structure of a single line if statement is like the following in the first cell, as you can see. Consider that you got a variable, for example, called val1, and it's equal to 10, and you want to create another variable. Okay, you want to define another variable which is based on an if statement like this one. Okay, based on if condition like this one. For example, if your val is equal to 2, val2 should be 20, is equal to 1, sorry. Val2 should be 20, otherwise it should be 10. This is how you can write your if statement. This is exactly equivalent to this 4 or 5 lines of code, but this is more concise and it is more Pythonic, and you can easily read it. So it is recommended to use this kind of if statement in just one line. I call it myself single line if statement. I don't know whether there is any kind of technical name for this, but this if statement comes in just one line, and it makes it super easy to read and maintain the code, because just simply compare this cell to this one. It includes more than, I don't know, 4 or 5 lines. Let me click on L, so the line numbers are visible now, and as you can see, we've got like 7 lines, but here we've got just 4 lines. So we save 3 lines just with one if statement, single line if statement. So as you can see, the condition is in this part, and then the else comes, and this is the output. The output is at the beginning. The output of the if is at the beginning, and the output of the else is at the end. Let me add the structure of it, so it would be easier structure. And let's call variable name equals to the output if a statement, if condition, let's put it that way, and else we may call it if output, and this one we may call it else output. So the output of else comes after else, but the output of the first if condition comes before if. So if this one is equal to true, this condition is true, you're gonna the variable is going to be set to 20, otherwise it is going to be set to 10. And as you can see, definitely val1 is not equal to 1, so the val2 will have 10 value. This is equivalent to exactly this lines of codes. So when should we not use if statement? If you've got more than 2 conditions, in that case you can have several if else statements. Okay, like this one that you can see. This is if, elif, and else, kind of it represents that. Let me tell you the structure. This is definitely variable name. This is the output of the first if condition, and then we've got an else. At the else part, you can have another single line if statement, another if statement that comes in one line. In here, it makes a little bit tricky, and it makes it a little bit hard to read the code. But if you are sure and you know what you're doing, and you've seen several of this kind of conditions, nested conditions, it's okay, you can use it, but it is not recommended because it makes it hard to maintain the code in future. But this is exactly like the one we just saw here. This is the output of the first if condition, then else come. This is the output of else. If else is passed, if this condition does not apply, the else will be activated, will be executed. And again, here, instead of just one single output for else, we've got another if statement, and the code runs this part, checks this part whether it is true or not. If, for example, here x is less than y, this one will be chosen as the output. Otherwise, again, the last one, or the output of this else, is going to be chosen as the output. And in this case, definitely x is less than y, so we're going to have less than sign, like this one here. And again, this is another example. It is better not to use more than one condition in one single if statement. It's better to just open it and write it in different lines, so it would be easier to comprehend and maintain the code in the future. So this was about if statement. We're going to see more examples in list comprehension as well. So let's talk about list comprehension. So list comprehensions. Why do we may want to use list comprehension? There are several reasons, but I have listed 3 of them here. They're easy to write. One of the reasons I like them is that they're concise and very expressive. It's you can easily understand what is going on, and the fact that it's concise makes makes it really convenient when you are coding. And whenever you use that, your code will be definitely much Pythonic, and it's fast. Again, we are going to see how it is fast. We have a test speed. And also, again, we mentioned it before, but it has a shorter syntax, like single if statement. So let's see an example of a usual loop a statement that we would have, or for a statement that we would have. This is our for a statement for I in range 10. It gets it starts from 0 to 10. The 10 is exclusive, and it's going to apply power of 2 to each number, and it's going to append it to squares, which is a list. So this is a usual way we used to use the for loops, but there is an easier way, which is called list comprehension. This is a list comprehension. The structure is here. At the beginning of your list, you've got your output. In output means you've got what you want to append to a new list. Okay, so list comprehensions returns a list. If you have a for loop, that at the end of that for loop you expect to create another list, in that case list comprehensions are the best option. So it is not like that you can convert any loop to list comprehension. It's not possible. Most of the loops that you expect to get another list variable from it, that's where list comprehension can play their role. Like this one here, as we saw in this example, we had a variable. We have a variable called squares. So we are creating a new list which is called a square. So we can change it to list comprehension. And we've got the brackets local, for defining lists. We've got the brackets at the beginning and at the end. At first, the output comes. What do you want to get as an output? Like this one that we appended to squares, so it can come at the beginning of our list. And this is the for condition, for a statement. Okay, or the for loop, for I in range. Okay, this is the usual for, and whatever we want to do with the the items that we get from range, we can write it here, or from our for loop we can put it here, and it will be as or output, or as the items of our new list, which is called scores. So as you can see, the output is the same, 0, 1, 4, 9. It applies exactly the power operation to power of 2 to our items from or for loop. So it is much easier and it is much faster. Its syntax is makes it super. The shorter syntax that it has makes it very convenient to use. So here I'm going to show you that it is faster than usual for loops, and we're going to see other options that it provides. As you can see, we've got like 1 million for I in range of 1 million, so we've got 1 million numbers, and we want to again apply power of 2 to these numbers. This is time it, and these are magic symbols for Jupyter Notebook. Using this time it, you can calculate the time of your cell, how long does it take. And as you can see, this usual for loop takes like 348 milliseconds, but list comprehension takes about 309 milliseconds. This is the same code, just converting it to list comprehension. It has a shorter syntax, and it is much faster than usual for loop without changing anything, because it is C optimized. Python has optimized these types of list for loops. So whenever you you find out that there is a chance that you can convert your usual normal for loop to a list comprehension, just do it. Definitely it's going to make your code faster. So one of the reasons that we can use list comprehension was a transformation, as mentioned here, data transformation and data filtering. We saw how we can apply data transformation. For here we've got, for example, 10 numbers, 0 to 10. We transform them to scores like this one. So one of the use cases of list comprehension is for data transformation. Another one is filtering. When you want to apply your for loop and you want to apply your a filter in it, the condition is like this one. Again, at the beginning, this is always at the beginning comes the output, then we've got the for loop, and at the end we can have a condition. Here, for example, it says we are going to create a scores variable, and we only want to apply power of 2, this operation, this transformation, whatever it is, it doesn't matter, only on those numbers that they are divisible to 3. Okay, the module of them divided by 3 is equal to 0. Only on those variables we want to apply. So this condition, as you can see, just I when it is equal to 0 and 3 and 6 and 9, this condition is met. So that's why we only have 4 numbers at the end. So you can use if condition, you can use single line if with list comprehension. If I want to show you how we may have done it in usual way that we already knew, we would have our like for statement, for loop, and we would say, let me copy this. For example, whenever if is divisible, whenever the items are divisible by 3, so then apply this here, apply this operation, and then append it to scores. like this one. So definitely this one line is much better, much faster. Obviously, I showed you the test, much faster than usual for statement and or usual if statement. So it's better to follow the combination of list comprehension and the single line if statement for applying the condition. So what if we want to apply transformation plus filtering while our condition is kind of if else statement. In that case, the structure is gonna change a little bit. The condition comes at the beginning like this one, and the for statement just moves to the end of our list like this one. The single line if is exactly interpreted like the ones we saw before, and they're gonna return actually we can't call it filtering because we're gonna have each time we're gonna have an item, so we can't call it filtering. Transformation is correct. So this if a statement is gonna applied to I or to the items taken from like 10 to 30 as shown here, and again if this condition is met, the I is gonna be the power of 3 is going to apply to I, or I is going to be to the power of 3. Else it's gonna write Puya. I don't know why I chose it, but just want to show you that if else statement, the single line if a statement can be applied to conditions like can be used in list comprehension like this one. So whenever you want to use if and else statement in list comprehension, you should bring that if and else to the beginning of your code, because it's not acting like a filter, it's not like a condition. It for each item it should return something, so it's not a condition. There is a subtle difference between these two. And we can have nested lists, nested list comprehensions like this one. This is the outer list, which starts from here and ends here. This is its for loop, and here comes its output. Again, its output could be another list comprehension. Again, I don't recommend this type of codes because it is a little bit complex, and it makes the process of maintaining a little bit harder than usual. So I don't recommend this type of applying list comprehensions as nested loops, or when you want to have model your two loops in just one list comprehension. It is not recommended unless you are an expert and you know what you're doing. In that case, it's up to you. You can do it as you want. This is a nested loop. As you can see, we've got lists as items, so it's possible we can have for loops as items, and also we can model two nested for loops like this one into a list comprehension, as you can see here. And you have to remember that this is the first loop, then comes the second loop. Okay, this is the K1 and this is the K2. The K2 comes after K1, so the order is preserved, and this is the output of both of them, both of these for loops. This is exactly equivalent to this one. Again, most of the times I recommend when you have two for loops, it's better to go on with this. But if you are an expert and you are used to using just different nested for loops, in that case, okay, go on, because you know that you are not going to introduce bugs, subtle bugs that may appear in this type of comprehensions, which are a little bit more complex than the previous one. So that's it for list comprehension. As you can see, they are very powerful, and you can, most of the time, you can apply them when you are creating a new list, new variable, which is a list. So what is dictionary comprehension? Again, like list comprehension, whenever you are creating another dictionary, which includes a for loop, you can use dictionary comprehension. The only difference is that you're going to use curly brackets instead of brackets. And here at the output, you got to have key and values, key and value, which are separated definitely by a colon, like a usual dictionary. And that's it. The rest is the same. Here we've got the for statement. We can have the condition at the end, and this is our output. So what does it say? What does it mean, this line of code? It simply says that I'm going to have numbers, items from 0 to 30, and there is a condition which says, oh, those numbers are going to be used that are divisible by 3. And also the transformation is that we are going to apply power of 2 to these numbers. And that's it. As you can see, only those numbers that their module when they're divided to 3 is 0, as you can see here, and these are the outputs when they are powered of 2. The numbers are taken to the power of 2, like here. So there is no difference between list comprehension and dictionary comprehension, just you need key and value as your output. You can use zip that we covered in previous videos. Well, zip is used to combine two iterable two lists or two dictionaries, and takes the items from both of them in order, in a sequence. Here, as you can see, we are taking K and V from keys and values like this one, and we are creating a new dictionary, which the keys are these numbers, and the values are these characters, and the values are the numbers. So inside your list or dictionary comprehension, you can use zip and anything that we covered about for loops. Let me see whether I have used enumerate. No, I haven't enumerate. So let me add a example about enumerate keys. Like let me call them values in this case, and here consider I've got just values, and I want to enumerate over values. So I'm gonna enumerate each item that I take from this list, and I'm gonna call it like en, and it could be like this, en. So again, you can use anything that you used to in your for statement. It's possible, like zip, enumerate, and other options that we had. They can be applied to a comprehension, whether it is a dictionary or it is a list. It's not gonna make any change. This is another transformation, which I'm not gonna get into it. So you can use as many transformation as you want. And again, here you can use if a statement in your if and else statement in your as your value or as your key. It's up to you. Just you have to remember to put it inside. I think if we don't put it, we don't wrap it with round brackets, we'll get an error. Okay, no, we don't get an error. Let me check the outputs. Yes, yeah, we don't get any error. Doesn't need to put it inside uh, round brackets. It doesn't need it. So Python realizes that whatever comes after colon is if statement, is values. So again, we can have nested dictionaries like the previous one. Nested for loops, it's possible you can have them, but again, I don't recommend it. It makes it a little bit complicated. Reading the code becomes a little bit complicated. So whenever somebody wants to read your code, they're going to kind of maybe spend a lot of time to understand what is going on, what is this list dictionary comprehension doing inside another dictionary comprehension. So it could make it a little bit hard to read and comprehend. But again, if you're working in a team that all of you are accustomed with list comprehension, so go on and use as many comprehensions as you want. So we covered list and dictionary comprehension, and we can also have set comprehensions. Again, like dictionaries, set comprehension should start with curly brackets, but they only have one output. They don't have key value. If you use key value, it's going to become a dictionary. But when you use one output, it's going to become a set. And as you can see, the other rules apply are the same for set, list, and dictionaries. Just the way that they are created and the way that they are created are different. And as you can see here, this for loop and the conditions are the same for a list and for a set comprehension. But because it's a set, um, it removes the redundant values, those values that are the same, and returns just the unique values. So this is the output of set, the first print output of set, which is 2 and 4, but the output of a list is 2, 4, 2, 2, but set just removes the redundant and returns only the unique ones. So this is all about set comprehension. I think this exercise should have been this exercise should be moved here because it is kind of it is about dictionaries. Yeah, one of the use cases I really like about dictionary comprehension is when I want to change the place of keys and values. When I want to do that, simply just a line of code like this one, which I iterate over the items, which returns key and value in each sequence. I get the key and value, and simply when I'm creating the reverse of that dictionary, I just replace them, substitute them with each other. The value comes first, so the value is taken as key, and the key just take the place of value, as you can see here. So if we've got like capitals, Iran, Tehran, and so on, the Tehran comes first and the Iran goes as a value. So this is another use case which shows you can easily use comprehension as well. So we talked about set comprehension, and let's talk about our last section. So whether we have tuple comprehension or not, because we kind of talked about all the sequence data types, 3 of them. Unfortunately or fortunately, we don't have tuple comprehension, and whenever you try to apply whatever we've talked about, and for example you want to change tuples, you want to change you want to use curly brackets, you want to use round brackets, so to get a tuple you'll get a generator. Okay, you're not going to get tuple, and as you know, the tuples definition of tuple is not dependent to this round brackets, and they are dependent to the middle commas, comma in between of the items only. But anyway, if you try to do something like this, you're gonna get generator. Generator is an object that we are going to cover in the future videos, not in this one. So just remember, you cannot create something like this. But if you really want to have a tuple, which is created like a comprehension, you can use this trick, which you can have your list like this one, list comprehension like this one, with all the extra features like condition. You can have it with the conditions, with the like if else statement, transformation, anything that you want. You can put them inside of a list comprehension, and after you put it inside a list comprehension, you can simply convert it to a tuple. So if in case you needed a trick to change to have a tuple comprehension, you can have whatever you want to do inside a list comprehension and simply just convert it to a tuple. So let me show you that it works. Yeah, as you can see, this is a tuple comprehension, kind of a tuple comprehension. So that's it for today's video. And like always, you can find the files of this video in my notebook, in my GitHub repository, and the link to the GitHub repository is in the video's description. Please consider to subscribe to the channel, like the video, click on the bell ring so you would be notified of the future videos, and introduce the channel and my GitHub repository to your friends. Like always, till the next video, have a great time.